Hi there. Hi everyone. Welcome to our last session of this Global Hack Week. We're going to finish our sessions about learning how to create scripts in Python. So the last session we learned things like how to create how to create hashes, how to encrypt information or data in Python using a cool library called uh, Hashlet, and the other library was called cryptography, I think. So today we're going to learn some projects and some cool information like analyzing packages, requests, and things like that. How to analyze requests via our the network and the package sent into our web page, or how to analyze data or information in that case. But first of all, let me just give you a real quick ad of 5 minutes. We're going to learn some cool things for the students about the student developer pack. So say hi to GitHub. So welcome today. So we're going to learn cool things about you can do as a student with the GitHub Student Developer Pack, the Global Campus, and all that stuff, right? So let me share my screen and let me first open the GitHub Student Developer Pack. So Student Developer Pack. So as a student, you have the benefits of claiming your GitHub Student Developer Pack. That basically is like a digital backpack that you have just for being a student. So this backpack is full of a lot of things like the virtual event kit, hackathons in the cloud, kit for aspiring creatives, your primary code spaces, career readiness into web development and data science and machine learning. So if you want to just create your portfolio, if you want to create your web page, you don't know how to code, you have cool tools like Bootstrap Studio or things like that that allows you to claim all these benefits. And like, for example, Bootstrap Studio is a cool tool that allows you to create a portfolio just by doing drag and drop. So it is cool. Also, if you want to have a cool domain for your web page, you also have cool domains like Namecheap, like name.com. Also, you have tech domains. So you have a lot of stuff real cool here. You can claim it just with your email. So also, if you want to create a application in the cloud, or if you are going to use some cloud services like, I don't know, computer vision or things like that, you can also use Microsoft Azure. Also, you can use Digital Ocean, and also you can use a lot of stuff. So like I said, this is the student developer pack. The student developer pack has all these experiences that you can have, or well, they are already built for you to so you can learn more about them. So if you're doing a hackathon and you want to create a form for registration or things like that, you have Typeform. Also, if you're going to use I don't know, if you need a web page for your hackathon, you can use Namecheap, you can use name.com, you can use tech domains. Also, you can use Heroku if you want to create an API for your hackathon or things like that, you know? So also, you can, if you're preparing for your next tech interview, you can use Educative that has a lot of trends coding skills for you. You can use also Algo Expert that is here. You have access to 20 coding interviews question to Algo Expert, as well as 10% discount on Algo Expert products. This is really cool. You have access to a lot of things. Also, if you want to learn something like, hey, I want to learn how to be a front-end developer. I want to learn something like how to become a machine learning engineer or data scientist. You have a lot of cool stuff here that can help you to create data science project, machine learning projects, and all the stuff. All right. So if you want to learn data science, machine learning, and all these things, you have data camp also. So like you're saying, this is full of a lot of cool resources, a lot of cool stuff, a lot of cool things that you can use. Also, if you're a student, you can apply to the GitHub Campus Expert program. Basically, GitHub Campus Experts are students who build technical communities on campus with training and support from GitHub. So if you want to create an event, you have support from GitHub. Like you have, I think, like almost $1,000 for event for each 2 months. So go there, claim your benefits. So for claiming your benefits, you just need to have a GitHub account. You have to have an email an educative email like I don't know that edu or something like that. So if you're in a college or in a boot camp or something like that, and they give to you an email, uh, you can use that email for claiming your GitHub student developer pack. But if you're not, you can just use something like a student ID or like your cardix or like your qualification and things like that, right? So yeah, just use your grades, and I think for that that should be it. Also, you have access to the global campus. The global campus is like a dashboard that helps you as a student to claim a lot of things, to see also some other projects from other students, like I don't know, like codes, like k-means clustering experiments, and all this stuff, right? This is called the community exchange. So the community exchange is a collection of student repositories for teaching, learning, and collaborating. So all of them are open source. You can go into community exchange. You can help others from open source projects to learn, collaborate, and all this stuff, right? So yeah, and finally, you have access to the GitHub octoships. That an octoship is basically it's like a fellowship where you have a company to develop applications or solutions, and you're going to be paid for that for participating in that company. Uh, you receive a stipend for each month that you are working with that company, and this allows you to learn by doing. And also, all of these companies are open source projects, I think. And yeah, it is really cool. So even you can see how many students have applied into each one of the internships. So this is not in all the countries. I think for now it is only in Mexico, Colombia, um, Nigeria, India, Pakistan, and some other countries that I'm not sure if there are. So yeah, so as you see, GitHub Education have a lot of stuff. I mean, you can access to the Campus TV that have a lot of cool stuff for you, and you even have events that are going to happen near to you. So yeah, just give it a try. Apply to the GitHub Student Developer Pack, and you will have access to the global campus, to your GitHub Student Developer Pack, and the GitHub Architecture. So that is all. I think that is that. So yeah, so let me read the comments. So Juriel can be the GitHub Silver project. Yeah, it is very valuable. So it is one of my favorite things about GitHub. And even you can claim it if you are just a student from high school. You don't need to be necessary from college or university. You can claim it if you are in a bootcamp or high school or things like that. Just try to apply. If your college is not in the GitHub Student Developer Pack, don't worry about it. Just try to contact your near campus expert, or you can send me a DM via Discord on the MLH server. And yeah, I think that should be it. So this is the end of the ads time. So now let's start again um, with our development. So let me change my screen to this one. Let me go into my GitHub profile, uh, go into my repositories, and let me select the global hack week, security week. So now we can start. And I forgot to sorry for that. A little bit more of ads. So a cool thing that you have as a student is that you have unlimited access to your GitHub code spaces. So GitHub code space is basically like a VM that you have in your browser, or you can imagine like your own IDE, your own space in your browser. Let me just open it. Like for accessing a code space, you just need to enter it to your repository and use each like whichever code space that you already have. So you just need to select the code space, open code space, and it's going to be setting up. And finally, ta-da! You're going to have your own IDE in your browser. It's basically like a Visual Studio Code IDE that you can use. It is customizable. You can use it anywhere from any computer that you have. You can access anywhere. So it is an all cool thing about this is that it is not going to use any kind of resources from your computer. Like for example, if you're going to run a web application, if you're going to run some data science project, machine learning project, you're not going to use any kind of resources from your computer. your RAM and also your processor is going to be running into a server of GitHub. Everything is going to be running in the cloud. So yeah, that's a really cool stuff. You can have like I think 10 or 5 code spaces for each account, and each of them, if you're a student, is going to be have your limited time, your limited time. So if you are not, I think you have to up to 80 hours, I think. So yeah, as you see, it is really just a Visual Studio Code IDE that you can use anywhere. You can install all the extensions that you want. You can even use GitHub Compile here. So that is really, really cool. And with that, I think that should be the end of the ads part. So let's start. Let's continue with our session. So our last session, we learned really cool things like how to calculate a hash, what a hashing is, some hash algorithms like MD5, SHA 256, and a, a lot of stuff. So also we learned how encrypting works, some encryption algorithms, what encryption was, how to what kind of encryptions were or like exist, like there's some symmetric encryption and asymmetric encryptions. And also in our first session, we'll learn things about like some basic Python functions, like how to manipulate the strings, how to handle files, open files, write files, and things like that, right? So also we used some code libraries like Hashlib and cryptography lib. So this helped like these libraries helped us to build some of these functions like generate key, encrypt key, decrypt key, use a lot of weird stuff and some cool things like Fernet that is basically a function or like a class from the cryptography Fernet model, and this helped to us to build a lot of cool functions. And finally, we created a RSA key pair that basically was a private key and a public key that help us to build some of our encryption code. So we ended up opening a file with all these things that are here. So as you can see, this is like our private key that is really long, is really, really cool. So yeah, we just use it to encrypt our message, and we use that key to create an asymmetric encryption that basically uses a key to encrypt and another key to decrypt the message. So we have this data. This data, we passed it into our ciphertext. We convert everything into ciphertext that basically is encrypted data. And after that, we decrypted our data, and we just print it out. And today we're going to learn some cool things about networking. And when I'm talking about networking, is like HTTP petitions, like how which kind of petitions exist, like post, put, get, and things like that, you know. And why do we want, or why do we care about this? We care about this because, well, let me open this. Uh, Let me open this file. As you can see, this file has a lot of information, like an IP. It has a lot of stuff. Basically, it has IP, transaction, like timestamps, and the important part that we care about now is like this, a petition, an HTTP petition. And why do we care about that? Because as you can see, whenever we are using like a product, like I don't know, if you're using your bank account, or if you're using I don't know, if you want to order some food or things like that, you're going to see that you're going to use an application, and that application is going to call an API, and that API is going to be somewhere in the internet. You know, it's going to be in a server in another part of the world where you can that is going to be uh, handling all these petitions that you're going to use. I don't know, if you want to order a pizza to your house, and you want to order that pizza from your application, from I don't know, Pizza Hut or Domino's application. I don't know. You're going to pass information to that API, and that API is going to handle your data to do stuff with that data, right? But that data is going to fly from your computer to somewhere in the internet, you know, and like magic is going to get into the server, and the server is going to handle your data, right? And how do we do that? How do we transfer that data? We're going to transfer that data by doing some um, HTTP processes, and we're going to do just look up at what an HTTP what is the difference about HTTP and HTTPS is, and also we're going to use all the calls, or we're going to learn all the calls that we can do in HTTP. And again, why do we care about this? We care because we use it anywhere. We use it in a lot of ways, and you can see these IPs are IPs from different persons that are using these. I think this file is on the Security Week server channel in the Black Hat Week server, on the MLH server, I mean. And as you see, we have a lot of routes, we have a lot of status and important data that we're going to look up. So the first thing about this is, let me search just in Google what HTTPS is. So let me share our data, and let's look up at this blocking Cloudflare. So let's try to first read this to try to understand a little bit better what is HTTP is. So I'm going to start reading. And so what is HTTP? Hypertext Transfer Protocol Secure is a secure version of HTTP, which is the primary protocol used to send data between a web browser and a website. HTTPS is encrypted in order to increase security data transfer. This is particularly important when users transmit sensitive data, such as by logging into a bank account, email service, or health service provider. Any website, especially those that require login credentials, should use HTTPS. In modern web browsers, such as Chrome, websites that do not use HTTPS are marked differently than those that are. Look for a padlock in the URL bar to signify the web page is secure. Web browsers take HTTPS seriously. So Google Chrome and other browsers flag all non-HTTPS websites as not secure. So I think you cannot see it, but this page has this like a lock icon that is between the URL and like the go back and go forward icons, right? So how does HTTP work? So HTTP uses an encryption protocol to encrypt communications. The protocol is called Transport Layer Security, TLS. Although formally it was known Secure Sockets Layer, SSL. This protocol secures communications by using what's known as asymmetric public key infrastructure. This type of security system uses two different keys to encrypt communications between the two parties. This was the thing that we looked up yesterday. We looked up at the difference between symmetric encryption and the difference of asymmetric encryption. So as we can see, this protocol uses communications by uses an asymmetric encryption, and it encrypts communication between the two parties. So the private key is a key that is controlled by the owner of a website, and it's kept as the reader may have speculated private. This key lives on a web server and is used to decrypt information encrypted by the public key. So the public key is a key available to everyone who wants to interact with the server in a way that is secure. So information that is encrypted by the public key can only be decrypted by the private key. So why does HTTP is important? What happens if a website doesn't have an HTTPS? So HTTPS prevents websites from having the information broadcast in a way that is easily viewed by anyone snooping on the network. When information is sent over regular HTTP, the information is broken into packets of data that can be easily sniffed using free software. So this makes communications over an insecure medium, such as public Wi-Fi, highly vulnerable to intersection, and in fact, all communications that occur over HTTP occur in plain text, making them highly accessible to anyone with the correct tools and vulnerable on the on-path attacks, right? So with HTTPS, traffic is encrypted such that even if the packets are sniffed or otherwise intercept, they'll come across as non-statistical characters. So let's look at an example. So before the encryption, this will be like our string. So this string says this is a string of text that is completely readable. So like you see, this is our text now encrypted. So one of the cool things about encryption is that encryption uses another thing called hashing. So hashing is the process of converting plain text into a lot of data. So this data uses some algorithms that are mathematically strong, as so they're so strong that a lot of if the attackers tries to access or obtains or string, it will be really hard to do it, right? So, and another cool thing about the hashing algorithms is that they have something called the avalanche effect. So imagine we have this same string, but if we add something like just a white space or anything like that, our our hash or our encrypted string will be as so different as this right now, and we just altered one character. So that's a cool thing that we have when we are encrypting things, right? So let's continue with our lecture. So in websites without HTTPS, it is possible for internet service providers, ISPs, or other intermediaries to inject content into web pages without the approval of website's owner. So this commonly takes the form of advertising, whereas ICP looking to increase revenue injects paid advertising into the web pages or their customers. Unsurprisingly, when this occurs, the profit for the advertisement and the quality control of those advertisements are not well shared with the website owner. HTTPS eliminates the ability of unmoderated third parties to inject advertising web in content. So, like, as we see right now, also we're going to read about ports. So HTTP uses port 443, differentiated HTTPS from HTTP, which uses port 80. So in networking, a port is a virtual software-based point where network connections start and end. So all network-connected computers expose numbers of ports to enable them to receive traffic. And also each port is associated with a specific process of service and different protocols of different ports. So how else is HTTP different from HTTP? Technically speaking, HTTPS is not separate from the protocol from HTTP. It is simply using TLS SSL encryption over the HTTP protocol. HTTP occurs based upon the transmission TLS SSL certificates, which verify that particular provider is who they say they are. All right. So this was the first step. That with the difference between HTTP and the HTTPS. So as we look up, HTTPS only encrypts it uses this encryption of the SSL and TLS encryption over the HTTP protocol. So that is cool. So if you want to learn more about HTTPS and HTTP, you can Google it. And also, I think you can read more about in the Mozilla documentation, like here, Mozilla. Yeah, you can use the developer.mozilla.org documentation, and you can learn more about the HTTP or hypertext transfer protocol. So I invite you to read and learn more about HTTP. But for now, we're going to use some of the, we're going to look about some of the HTTP protocols, I think. HTTP requests, sorry. And let's read it from Mozilla also. So we're going to read something about the, let me change this to English. So let's read something about HTTP request methods so we can learn more about the difference between each other. So yeah, so HTTP request methods. So HTTP defines a set of request methods to indicate the desired action to be performed for a given resource. Although they can also be nouns, there's request methods. These request methods, sometimes referred to as HTTP verbs, each of them implements a different semantic, but some common features are shared by a group of them. An example, a request method can be safe, independent, or casual. So the first method that we're going to look up is get. So the get method requests a representation of the specified resource. Requests using get should only retrieve data. The head method asks for the response identical to get request, but without the response body. You just want the head. So post method submits an entity to the specified resource, often causing a change in the state or side effects of the server. The put method replaces all current representation of target resources without the request payload. So delete. The delete method deletes the specified resource and connect the connect method establishes a tunnel to the server identified by the target resource. Options. The option method describes the communication options for the target resource. Trace. The trace method performs a message loopback test along the path of the target resource. Patch, and finally we have patch. The patch method applies a partial modifications to our resource. Most of the time we're just going to use post, pod, delete, and get. And also we're going to use head, but don't worry about this. So as you can see, a lot of browsers are compatible with most of these, most of the HTTP request methods. So also we can see some of the headers. This is really important. And I think, well, let's read it and then I'm going to explain something. So HTTP headers. HTTP headers let the client and the server pass additional information with an HTTP request or response. An HTTP header consists of the case-insensitive name followed by a colon, then its value. White space before the value is ignored. So custom party property headers have historically been used with an X prefix, but this convention was duplicated in June 2012 because of the inconveniences it caused when non-standard fields became standards in the RFC 6648. Orders are listed in a IANA registry, whose original content was defined in RFC 4229. IANA also maintains registry proposed new HTTP headers. Headers can be grouped according to the context. Request headers, response headers, representation headers, and payload headers. So headers can also be grouped according to proxies handle them. Connection, keep alive, proxy authenticate, proxy authorization, TE, traveler, transfer encoding, and upgrade. So end-to-end headers are end-to-end headers. These headers must be transmitted to the final recipient of a message, the server of a request, or the client for a response. Intermediate proxies must retransmit these headers, modify, and caches must store them. Hop-by-hop headers. These headers are mainly only for a single transport level connection and must not be retransmitted by proxies or cache. Note that only hop-by-hop headers may be set using the connection header. So most of the time we are going to use these headers for authenticating that I have access to that URL that or that HTTP URL that I'm trying to access. So for example, if I want to create a new object into my API and I'm trying to send that request from another website, I should pass some things in the header like, hey, I have a password to enter to this API to add something to this URL. Or hey, I want to do it in this way or in another way. So most of the time we're going to use our headers to specify some of the authenticating access data that we have, right? So now we're going to talk about authentication. So a www 3W authenticate defines the authentication method that should be used to access a resource. Authorization contains the credentials to authenticate a user agent with a server. Proxy authenticate defines the authentication method that should be used to access a resource behind a proxy server. So proxy authorization contains the credentials to authenticate a user agent with a proxy server. Also, we're going to talk about caching. So what is caching? Let's search this about caching. So what is caching? And let me search this in Mozilla also. So let me change this to English and change this. So HTTP caching. So the HTTP cache stores a response associated with the request and uses the stored response for subsequent requests. There are several advantages of reusability. First, since there is no need to deliver the request to the origin server, then the closer the client and the cache are, the faster the response will be. So the most typical example is where the browser itself stores a cache for browser requests, and also when a response is reusable, the origin server does not need to process the request, so it does not need to parse and route the request, restore the session based on that cookie. So query the DB for results or render the template engine that reduces the load on the server. So proper operation of the cache is critical to the health of the system. So there are a lot of types of caches, like private cache and shared cache and proxy caches. The one we were reading about was the proxy caches. So let's read it about. So in addition to the function of access control, some proxies implement caching to reduce traffic out of the network. This is usually not managed by the service developer, so it must be controlled to appropriate HTTP headers and so on. However, in the past, outdated proxy cache implementations, such as implementations that do not properly understand the HTTP caching standard, have often caused problems for developers, like kitchen sink headers. Kitchen sink headers like the following are used to try to work around an old and not updated proxy cache implementation that do not understand current HTTP caching spec directives like no store or things like that. Right, so let's continue with the HTTP caching here. And also where we have on the like we are saying, there are so more headers. So I don't want to overwhelm you with a lot of information and theory. So what do you think if we understand a little bit more these by doing some examples in Python? So let me go to our code space that we were using here. So for this occasion, we're going to use a library called Skype. So first, let's install this. So pip install Skype. Why do we care about Skype? So we're going to use Skype because it is a cool library that we can use for analyze a network package into our computer. So we can build a program or a script in Python using this library to capture and analyze network packages, and we can implement these functionalities as a traffic suspicious traffic detection or things like that, protocol identification, and analyze some patterns in our packages that we captured. So now that it is installed, let's try to do an example here. And let me just type something. And let's go. So now that we have this, let's try to simulate that we're going to catch all of this information. So last time we created a class object. No, I think we just created the object, or like the dictionary that takes all this file and extracts all the information that we wanted to use and how we can authenticate this, right? So let's try to simulate something. So a cool thing that we can detect with this file is that we can detect suspicious use of suspicious packages networking. Like, I don't know, maybe I have a website that has an API that you can post new authentication, or you can create a new item that is going to be in our database or things like that. But maybe someone wants to create make like 10,000 petitions for each second, right? So that will kill our server, and we need to ensure that we're not going to pass by that, right? So with this, we can ensure, like, hey, if the same IP is creating the 10,000 petitions in just 1 second, hey, maybe this person have access to my API. Maybe this person is a hacker. So what should I do is to I don't know, but maybe I should ban this IP and try to keep moving with that, right? So what do you think if we try to do that, right? What do you think if we try to identify this? So let me just create a new class. We're going to add a new file that is going to be network detector, network manager.py. And this network manager is going to have a class called network manager. And let's try to first initialize this class, like the init. And this is going to receive something that is going to be our file. yeah, I think for now we're just going to have a file and self and file, and file is going to be equal to file. Self.file is going to be equal to file. And now let's try to define an option that's going to be def check IP, and this is going to be using file. So for now, we're just going to detect this, right? So I think we created this here. Let me search for this. Yeah, so we already did it here. So for obtaining all the information that we need, we're going to have another variable called transaction, and this transaction is going to be equal to nothing. Transaction. Oh, but I think we don't need to do it this way. This is going to be a dictionary. So now let me open this in the correct way. So with this, let me uncomment everything and pass this here. So we should first create this like read file. And after we read the file, we should now use like the detect IP. Def detect IP. And with this, now we should be able to do it. So after we finish like implementing all of our transaction, we should change the value of a transaction, right? So self.transaction is equal to, or I mean, even we don't need this. We can just say something like self.transaction is going to be equal to this, right? So okay, so what we're doing here is just we first create our network manager class. We initialize our class object. So our object is just going to receive a file and is going to initialize a transaction variable. This is going to be a dictionary at the start, but then we are going to read our file that we receive, right? So as we receive our file, we're just going to use, I forgot to add self and self also. So I forgot to add it. So yeah, so as we are reading our file, we'll be handling our file to try to extract all the information for all the important information of our file for each one of these. So as you're seeing, as you are reading, we are extracting the IP, the timestamp, the kind of petition route, version status, and completed time. That is basically all the information that we have on our Apache access by IP file. So yeah, basically we're just extracting the IP, the timestamp, the kind of petition that we're doing, the route where we are doing that petition, and the HTTP version that we're using, and the status of our petition, and I think this is just like the time that we use to complete the petition. And yeah, I think with that should be all. Now we are going to let's start trying to build this function that we're going to use here that is called detect IP. So detect IP is going to be just a basic function that is going to count the number of IPs that we have. So if we have an IP, let's try to extract this. And oh yeah, I forgot. I totally forgot this. So we're going to use transactions, and each one of these transactions is going to be here. So sorry for this. This should be this transaction, and for modifying or for adding this transaction into our transactions into our transactions array, we're going to use our transactions list. We're just going to do self that transactions that append transaction. And with this, this should be it. So for each one of the transactions that we have, we should, like, for doing this, we should detect let's think of how can we do this. So for just detecting the same IP or the amounts of IPs, um, the first thing that we should be able to do is to detect or like count all the different IPs that we have, and after that we should be. I think a cool thing that we can do is to just try to find the most repeated IP that we have in all of our time, and after that try to see the amount of repetitions that we have of that IP, and try to search, then compare like the differentiation, like the difference of time in each one of the transaction of the same IP, right? So for doing this, we should do something like, I don't know, maybe like, hey, for each one of the, so let's try to do transactions for each transaction in self.transactions. Let's try to count counted IPs, right? So we should need IPs IPs dictionary, and this IP dictionary is going to have the IP and the value of the counted IP, right? So for each transaction in transactions, let's just try to add it, right? So transaction of IP, the IP of transaction is going to be equal to IPs of transaction IP. But the first thing that we should be able to do is just to ask if the transaction is in our IPs dictionary, then add a value to it, but if not, add it, right? So if transaction in IPs, transaction of, IPs of transaction is more or equal to 1. So we add up to 1. If not, we just add transaction of IP is equal to 1, right? So after that, we have counted each IP, So if transaction inside the transaction, if the transaction is, if the IP is in IPs, then IPs of the IP. Right. So let's bring this. Let's try to read this again. So we first create a function called detect IPs. We pass our object that we initialize here. This is going to have all the transactions that we already read into our read file function. So we first initialize an IP dictionary, and this IP dictionary is going to be storing all the IPs of all the transactions that we have done. So we're going to traverse all of our transactions list, and we're going to try to read for each transaction, bring the IP or like pass the IP of the transaction. So let's try to change this. If the IP of the transaction exists in our IPs dictionary, then that means that it is already in the dictionary, right? So we just need to add one counter we need to count one more into our values dictionary, right? But if not, we need to initialize it. So then let's try to see if this can print it out, right? So print IPs. So yeah, let's try to do this and to put it into our main file. Let me again comment all of this section. Let me comment this chunk of code under DC. And after doing this, I think we should just need to import our class. So from network manager, import network manager. So yeah, I think that should be all. So let's try to create a new network manager. So let's try to translate this, right? So network manager is going to be equal to a new network manager, and we need to pass the file that we're going to use, right? So the file is going to be equal to Apache access. No, I mean, even we don't need to pass a file, but we change this because the file we already had it, right? So yeah, we already have the file. Maybe in the future we can modify the class to have or like have multiple files or anything like that. But for now, I think we don't need it. So yeah, let's just continue with this. So we have our files here, blah blah blah, and I think we should be able to do it right now. So for network manager, so then we should first read our file. So network manager dot read file, and yeah, first we should need to read our file, and then we should be able to run network manager dot that detect IP and detect IP, and now let's see if this works. Sorry for that. I meant to put Python main.py, and name IP is not defined. Do you mean IPs? All right, I forget how that. Blah blah. Section of IP. Yeah, right. You're right. So if the IP of the transaction, if transaction.ip exists in IPs, if transaction IP, the IP of transactions exists in IPs. Yeah, if the IP of the transaction exists in IPs, then transaction of IP plus 1. Yeah, so again, we first create a function that is called the IP, then we add then we create a dictionary called IPs. Then for each transaction in in the transaction list, we're going to see if the IP of the transaction exists in IPs. Then we add then that means that it exists, and we just need to add 1 to the value. But if not, we need to initialize it with 1. So then we need to print the IP dictionary. So what's going on here? So let's see if this transaction. So yeah, it does. So what is going on here? So should I use transaction.ip? I don't know. Maybe let's print it this way. So print transaction IP. So yeah, maybe we should just need to use a point instead of this. So the has an attribute IP. So what does it have? So it has a value, blah blah. So if the transaction of IP exists in IPs, all right. Yeah. So I'm totally forgetting this. So yeah. Sorry for that. I'm not even accessing to the dictionary. Yeah. So I was thinking about what is going on here. So we ask if we are asking if the transaction exists in the IP dictionary, right? But then we don't do anything. We just modify the transaction. So we need to add it to the IPs. So we first need to initialize this into our IPs dictionary. So we pass the value of transaction IP. We pass the IP of that transaction. If it exists in IPs, then we need to initialize it in our IPs dictionary, we initialize it with a value of 1. But if not, that means that it already exists and we just need to add a 1 to the value, right? So we put transaction of IP, like the IP of that transaction in the IPs. Like if it exists, we put it, we just add 1 value to it. But if not, we just initialize it with 1. So yeah, now let me run it. Yeah, now it works. So as you see, we have a lot of stuff here. So let me just claim this, like here, and let me put this here, and to Python.mine, Python.mine, and I think I'm printing something else. I'm printing something else. I think so. No, I think for now we should be ready to go. And I think that is all. I think that should be all. I think. Hi, Aman. How are you? Yeah. So if you're counting to stream, we already have covered what HTTP and HTTPS are, the difference between them. We have read something like we read something about the HTTP requests, and now we're just doing some exercise with our Apache Access library, Apache Access file that we have, and now we're just trying to obtain all the IPs and try to count them, and then try to know if some of our IPs have been repeated, and if they're trying to try to get down our server, But we have reached the hour, so what do you think if we take just a 5 minutes break? All right, so go there, drink some water, and we'll be back, right? And I'll be back in 5 minutes. So I'll see you in 5 minutes. Hey everyone, welcome again. I'm back. If you have come into the stream, we're just looking up into some cool things about building a Python class that can detect if an IP has been trying to take down our server by making 10,000 petitions into our API or something like that, right? So this is just a simulation. We're just trying to build our Python program that can detect if our IP has been trying to make tons of petitions into our server in just a little bit of time, right? So with that, we have just built a dictionary that takes all the IPs, and by taking all the IPs, now we can just do some cool stuff like trying to look up and try to order our dictionary by its value. But I think in this example, all of the IPs that we have right now have just something like yeah, there are just unique IPs. They're just making just one transaction per minute per second. Like they have just been trying to make one transaction per IP, but we can make an example where some IP have thousands of petitions, right? So let me just copy and paste this. Someone is making a get. So yeah, so maybe this person is trying to take us down, right? So uh, so let me copy and paste this here. So I think with this, we should be able to see what I'm trying to explain. And let me just put another one. And with this, now let's rerun our program. So with this, now we have someone that says, all right, what are you? I think it should be good if we just try to delete some IPs here. Like in this part, like here. Let me just cut this out and put it out here. And what is going on? Blah, blah, blah. Plus equal 1. I think we're just initializing each one of the IPs that we have. So we have all these transactions. So if IPs of the transaction, if it exists, we initialize it with 1. But if it exists already, then plus equal 1. If the transaction exists, oh yeah, else, and do that stuff, right? So yeah, now it works. Sorry for that. And yeah, now we have all this. So welcome everyone who's coming today. So hello Oluwaka Yode, Oluwaki Yode. I don't know how to pronounce this. Also hello to Amaksheshi and Ejekson. So welcome everyone. This is our last stream that we're going to do in the Global Hack Week. This is our last session. So cool. Let's continue with this. We have built everything that we need. So we now have count like all the amounts that we have. And now what do we need to do? So it would be great to order this, but I think ordering something like this will take a lot of time. But for now, what if we try to ask ChatGPT how we can order our Surda dictionary by its value, right? So let's try to ask this to ChatGPT, right? So let's ask ChatGPT, imagine that I have a dictionary with IPs with different and a value. How can I sort this dictionary by its value? So with this, to sort the dictionary with its value, we can use the sorted function along with a lambda function that as the key parameter. This is example. So we have the simple dictionary that has all of our IPs. So sort the dictionary of the values in ascending order. So sorted dict is equal to dict sorted key lambda item 1. So I think we first convert this into a list and we pass like the IP and then the value, right? And we are trying to, so we are passing the items. We're trying to extract each of the elements of each one of our IPs, and we sort our dictionary by just using that, right? So for each IP and value inserted that items, we are going to bring the IP and the value. So for now, I think we just care about sorting the dictionary. So we can use something like this. And let me pass this here. So sorted is going to be dict sorted, the IPs items. And yeah, I think for now we should sorted IPs. We should pass just sorted IPs, right? So let me run this again. And yeah, so now we have our dictionary already sorted at the end. So yeah, I think with this, everything should be ready to go. So now that we have seen that the IP of 249 and that 139, that 157, that 148 is the one who is trying to catch up us. A cool approach will be to see to pass into all of our, like, because we have already all of these, like all of the transactions that have been done into our code. A cool thing that we should be able to do is to just try to pass for all the transactions and get its value and try to see if he's trying to getting us down, right? So a cool thing that we can do with this is just try to traverse all of our dictionary, the dictionary of transactions that we have, or like the list of transactions that we have. Try to keep up to look up at the IP with the maximum value. So for that, we should be able to just get the maximum value. Maybe we can use the max function for that. So let's actually try to do, how can I get the max value of all the dictionary of IPs? So I think we should be able to do it by just using the max function. And yeah, we should be able to do the maximum value. And for getting the keys, so the maximum function returns blah blah. If you want to find the corresponding keys associated with the maximum value, you can use the dictionary comprehension for a loop to iterate through the dictionary and check for matches. Here's an example. So for each max keys, K for K and B in items, if B is equal to maximum value, okay, yeah, this should be good. So for each K is going to be 4 keys, and for each key and value in the IP of dictionary items. So if the value is equal to our maximum value, then we're going to associate that key, right? So we should be able to do that. So with this, I think we actually don't need to do that. So we actually don't need to sort this. We should be able to just get the maximum key. So for getting the maximum key, the maximum value, we should be able to do it by just max value is equal to IPs max of IP, getting the maximum value of IPs dot values. Now we have value function, and now we need to check up for the key of maximum value is equal to, we need to create for each case going to be 4 keys. Oh yeah, you're seeing this. So now I think you're able to see, right? So for So let me just copy and paste this. K is going to be K for K, B. So let's try to do it this way. For each key in for key and value in IP dictionary, this is IPs.items if value is equal to max value. Blah, blah. So let's try to read this again. So we first initialize and try to find the maximum value in our dictionary, IP dictionary. So after doing this, after getting the maximum value, now we are going to try to find out which key has that maximum value, right? So for each, we're going to initialize a variable of key of maximum value. So we're going to initialize another variable called key, and this key is going to be here for each key and value in IPs that items, and we're going to find out if that value is equal to max value, right? So yeah, let's try to do that. So let me try to run this and see if the IP corresponds, right? So let's try to print the max value, key of max value, comma, this, comma, and max value, right? So let me do this, and yeah, I think now we are able to go. And I don't know what is printing here. Something is printing here, but I don't know why. What is going on? Something is printing itself, and I think it's this thing. So we have self-transaction and yeah, what's this thing? Just for that. And let me clear this. And yeah, now we have our IP, that is the key, and we have the amount of times that it was trying to get us, right? So we know now that the IP that was trying to get us was this IP. It wanted to request something 74 times. So now we should be able to do something with this, right? So for this, now we'll be able to do it in something like, let me think. Okay, so now that we have it, now that we know which key is the one that we need to search, we want to look up at the difference between times. So let's try to think, right? So let's try to read this again. And how do we know when a different, or like if we're trying to do the same, like which one is going to be our limiter? Because maybe someone is trying to access our web like one time and it's going to refresh 1, 2, 3, or 4, 5 times, but the time for refreshing should be like more than 2 or 3 seconds, right? But if the petition is from the same IP in, like, I don't know, if the IP wants to create a petition for the same moment or like in a time lapse of 2 seconds, and the difference of the petition is in less than 1 millisecond or like something like that, that should be something, right? So what can we do with this? So let's try to make the rules. So again, let's try to make the rules. So if the IP wants creates or makes a request in a time lapse of less than 2 seconds or like 3 seconds, less than 3 seconds, we should ban that IP, but how many times? If the IP makes a request in time lapse of 3 seconds, let's try to look up at the counter. So if the amount of requests is greater than should I give a number like 10? yeah, like 15, greater than 15. Um, hmm. Well, let's just ban that, or like let's have like a new dictionary called ban IPs, and we're going to add the IP to the IP banned IPs dictionary, right? And if that person keeps wants to try or tries again to make a petition, and we're going to look up at the banned IPs, and we're just going to ignore that petition or like block that petition or send out something, right? So because this is just a simulation, we don't have uh, that power, but we can just send a message to that detects that, like, hey, you're banned now, right? So add IP to the banned stick, and before that, we're going to run again, or like keep traversing our dictionary and just look up at the banned IPs. If a banned IP appears, send a message that says, hey, you're banned. And something like this. Okay, so again, the rules are: if the IP makes a request in a time of less than 3 seconds, then we're going to ask. If the amount of requests is greater than 15, and then add the IP to the banned IPs dictionary. So then after putting that, we can keep traversing our dictionary and look up at the banned IPs, right? So if the banned IP appears, we're just going to send a message to say, hey, you're banned. And that should be it. I think that should be it for now. If you have an idea or if you want to suggest something, you can make a comment. You can say whatever you want. If you have a question, you can also make the question. And yeah, let's just try to continue with this. So I have a question. Have you ever done an exercise like this ever? Have you ever worked with IPs? Have you ever worked with anything like that? And I want to know also how your Level Hack Week has been. Have you learned something? Have you done anything special? Can you comment if you have fun in the mini games or something like that? I know a coach who is real good called Alberto. So you want to see their streams, don't forget to subscribe to the MLS Twitch channel, and whenever you see an stream that Alberto is going to host, join it and have a great time with it. So yeah, let's just try to read the rules again and make whatever we want to do it. So we're going to do this. We should be traversing the IP's dictionary, right? So again, let's try to do it. So where it was, transactions. So now we're going to do this again. So for each transaction in self that transactions, we're going to look up at if transaction of IP, the IP of the transaction is equal to the no, actually, if the transaction key is equal, oh yeah, if the transaction IP is equal to the key of the max value, instead of doing this key, it should be like IP of max value, right? So the IP, instead of doing this, it should be like, hey, if the IP of the max value is equal to the IP that we are traversing, then we should be able to see like at a counter. And do that again, right? So let's initialize a counter here, like repetitions, or like number of petitions this is going to be equal to 0. So now we're going to do this and forget about this. And now if the transaction that we're traversing is equal to the IP, well, I mean, if the IP that we're traversing, again, if the transaction that we're traversing has an IP equal to the IP of the max value, we should be able to just increase the value of the number of petitions of that IP, right? So the number of petitions should be more equal than 1. And again, if the amount of requests is greater than, we should be able to see if the number, we should be able to ask if the number of petitions is equal to 15, then we should add that IP of max value to I forget to add that dictionary, right? Band IPs is going to be equal to an empty dictionary. So band IPs max value here you are. The IP of max value is going to be equal to 1, I think. And yeah, I think with that should be everything. So band of we add that to our IPs of max to our band IPs dictionary, and if not, we should be able to see it, right? So all right, so if the transaction IP is equal to IP of max value, first, and the transaction of IP is not in the band IPs, then we should be able to do this. Else, that means that it's banned. Then we should print just the transaction IP and say, hey, you're banned, right? So let's try to do the transaction IP. Let's try to print this. Sorry, IP. And say, and kind of comma and say, hey, you're banned. Okay. Here, hey, you're banned, and yeah, I think for now that should be all. So let's try to run this up, and first let's try to see if this is going to work. So we first initialize the number of petitions, we add the banned IPs, and for each transaction in sub-transactions, for each transaction in the transaction list that we have, first we ask, hey, is the transaction IP is equal to the IP of the maximum value? And also, is the transaction IP is not in the banned IPs, in the banned IPs dictionary? So if this is true, then we're going to ask, hey, is the number of petitions already equal to 15? If it is equal to 15, then we're going to add, we're going to update our banned IPs dictionary. We're going to add the IP of the max value. I mean, we're going to add the transaction IP. Transaction IP. Yeah, we're going to add the transaction IP. Or no, yeah, I think it's correct. The IP of max value, right? Because we're asking here. So the banned IPs are how we're just going to update our banned IPs and add the IP of max value. It's going to be equal to 1, and if not, we're just going to add one more transaction to the number of petitions. I mean, we're going to increase the value of number of petitions to 1. But if not, that means that it is banned, and we're just going to print, hey, transaction, you're banned. Hey, IP, you're banned. And yeah, I think that should be all. Let's try to run this and see if this works. And transaction IP is not blah 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 blah. Where did I ask that? Uh, transaction IP. Where did I put this? 935. Oh yeah. So put this and how it takes it. But I forget to see what it is. And number of petitions should be equal to 0. And so I can see this. Hey, Urbana, If the transaction of IP is equal to the max value and the transaction IP is not in bound IPs. Should have something else to this. And so, well, it appears that a lot of times. So let's try to see where it appears. And we're trying to do this. And I think I'm forgetting something here in the logic. So let me check it again. So for each transaction, if the transaction IP is equal to the IP of max value, and the transaction IP is not in the bound IPs, all right, then we ask if the number of petition is equal to 15. But I mean, it does it with everything, right? So should we do it just like this way? If the transaction IP is equal to number of IPs, and then do something like this, and remove this here like to this. If the transaction IP is equal to IP of the max value, and then ask if the transaction IP is now the bound IPs, then we do it, but else we are bound. It's the same thing, right? So the transaction IP is not in bound IPs. But what is the same working? We added to. We make this. We add the number of petitions. Yeah. Now it doesn't print anything. So I think I'm forgetting to add something. All right. Let me read this again. For the transaction is blah blah blah. So if the number of petitions is equal to 15, then bounded IPs is going to be equal to 1. But if not, what's going on? All right. So if the bound IPs is equal to then print the transaction IP, right? Transaction of IP. Print the transaction of IP to see if it is the same IP. Then we add it to the dictionary. Then we restart the number of petitions. And should we first ask the number if the transaction is on IPs, right? So if the transaction is not in binary IPs, then you can continue, right? Because if it is not, then I think it doesn't matter. So if the transaction IP is not in IPs, else your band, and let's move this here. And I think in this way, if the transaction IP is not in bound IPs, then you can continue, right? So if the transaction IP is equal to max value, then we ask, hey, the number of petitions, is the number of petitions equal to 50? Yeah. So if it is, then do something. If not, then just add 1, right? So, interesting. So, I mean, yeah, right? So if the transaction is in bound IPs, then just print, hey, you're in your bond. Yeah, I think I'm making a mess here. So let me restart this again. So the first thing that we should be able to do is to just ask, hey, is your transaction in the binary IPs? So if the transaction is in binary IPs, then we should just print, hey, your bond, right? So, and if not, we should be able to do something else, like ask all of these, right? So, all right. So, hey, if the transaction is in if it's in the bound IPs, just print hey you're bound. But if not, just continue, right? So, ask the transaction IP is equal to the IP of max value. Yes, it is. So if it is, then ask again, hey, the number of petition is 50. So if it is, then print the transaction IP and blah blah. And all right. So let me see if this is working on print transaction. And this is going through the loop. So print counter, the number of petitions. So it's always 0. So why is it always 0? So if the transaction IP is equal of the IP of max value, print IP, transaction IP, transaction IP. Let's see, making this. No, in the transaction IP. Oh yeah, I think it is because of the thing. So what is transaction IP? So let me print just the transaction IP and the transaction max value, the IP of max value. Let me print the IP of max value and the IP of the transaction. Right. So. Oh, I get it. That is why. Yeah. The IP of max value is a list, right? Yeah. I forgot to add it, pass it to just one. So, all right. Yeah. So it should be just the list of 0. So we have a list. We'll be able to do it this way. Yeah, now it works. All right. So now let me quit this up and quit the transaction IP. And this way. Also, let me keep the number of petitions, the number of IPs. And yeah, now it just only bans our transaction here. So the problem was that we were trying to compare, like we were extracting the IP of the max value, like the IP that, like comparing the keys. So after comparing the keys, we were like comparing a list with an actual string. So in that way, we will never be able to compare our values and do some stuff. So now at the end we can just see the band IPs here. So let me print finally the band IPs to see the difference between like which one is the IP that is banned. And yeah, I think that would be all, right? We have completed like our exercise in this simulation. So with this now we can see like how we can manipulate some IPs and how we can manipulate like the number of petitions that we have, right? So we have created like asking if the petition is banned, but we have not compared the time lapse. That will be another thing that we should be able to do. So yeah, let's see if we can. We have compared like the amount of the amount of requests that we have done, but we have not compared the time lapse, right? So for comparing the time lapse, we should be able to do it by just comparing the value between the seconds that we have. For comparing the seconds, we should be able to compare to first get the difference of seconds between each one of the transactions that we are doing, right? So with this, let's try to ask how to obtain that with ChatGPT. So for doing this, let's try to ask ChatGPT how to do this, right? So imagine that I have another value in the dictionary, or well, imagine that I have a dictionary with some values, a list of IPs that have the IP value and the timestamp of the transaction, like this. Let me copy and paste the transaction. Let me get first the transaction IP because I didn't print it. So print transactions. Let me put it down here. I have to maintain the print and transactions. Self.transaction, I forget print self.transactions. Self.transactions, and now we have the timestamp. Like this. I'll have it. So how can I get the difference of seconds between each petition? Yeah, how can I get the difference of seconds between each petition? So let's try to see how we can get that, and with that we should be able to just get the difference, and if the difference is less than 3, I think we should be able to do it. So all right, so from datetime for datetime, so we have the simple dictionary. So to calculate the difference in seconds between each petition in the dictionary with IP addresses and timestamps, you can parse the timestamps into datetime objects, then calculate the difference between consecutive entries. So here's an example, right? So we have our timestamps and we have the seconds. So convert timestamps to timestamps. So we first convert datetime list. So the datetime that is the period time entry timestamp. All right. So for entry in IPD, so for each entry in the dictionary, so then we calculate the time difference in seconds. So the time diff is going to be the list. All right, 2 total seconds. So for each in range, all right. So then we print the differences. Um, all right. So, but what if I just have two ones? I think you should work. But why do we use the minus one? I have the doubt why we're using this I minus one. So let me ask ChatGPT if he can explain a little bit better this. So can you explain a little bit more what does the line do? So let's break down the line. So the time diff list is equal to daytime list. All right. So first, for I in range 1 to len, this is all of the iterates over the range indices from 1 to the length of the time. It starts at index 1 because we want to calculate the time difference between the consecutive entries. All right, yeah, I got it. So the time inside the loop, this expression is abstract the datetime object in the current index I from the datetime object at the previous index. So this gives us the time difference between the two entries. So the total seconds resulting difference is a time delta object, and we can call the total seconds method to convert the time difference into a float value, representing the time difference in seconds. So the time expression generates a list comprehension, then it iterates over the range of indices and calculates the time difference in seconds between the consecutive entries, creating a new list called time diff list with these values. So to clarify with example, let's say we have the following time. All right. Yeah. I got it. So the list comprehension will iterate over the indices 1 to 3. So this will be 1, 2, 3. As the length of the all right. All right, got it. So we'll get the difference between each one of them, right? So yeah, I think for now we should be able to do this in this way. So let me just copy and paste this. So the datetime list will be here. All right, so we have already our dictionary. We're trying to. So to get the difference between each one of them, we should be able to get the difference of time, right? Because we want to get the time lapse that has been created in the time lapse. So let's try to do that, right? So transaction how, then we don't care, right? So let's just first get the time lapse, and then compare the time lapse and secure that the number of petitions not equal to 15. So, all right, let's try to do that. So for these, we should be able to do it in this way. So for getting the time lapse, we should be able to do it by just asking, hey, the time lapse, I think it was total time. The function was like total time. So for doing this, I think we should be able first to get the timestamp. So let me again just break down the function time list. So can you explain? Can you do the same for this line? I want to know a little bit more about this line. So, all right. So for entry, this is a little bit that it traces over each entry. So datetime s3 inside the loop, this expression retrieves the value associated with the key timestamp in each entry dictionary. It then uses a strpr time method from the datetime model to convert the timestamp string using datetime object to form a string. Day specifies the expected format of the timestamp to perform the conversion correctly. The entire expression that generates list comprehension. It iterates over entries in ipdict and then creates a new list data and list with resulting data objects. So have the IP, So the list comprehension will iterate over each entry in ipdict, retrieve the timestamp value from each entry, and convert it into a datetime object using the specified format string. The result datetime list will be this. And what if I want to do? What if I want to do? What if I want to extract? Well, if we have the datetime already, like we should be able to do it in this way, right? So, well, I think for now we won't be able to finish this session because we have just like 5 minutes later, and I have to give 5 minutes to the next streamer. So I think we should not be able to. Well, we won't be able to finish our session today. So sorry for that. I think we. Yeah, the code. Let me make the just let me make the push to our repository that we're using today. So let me ask. Let me put this like exercise. Finish at 90% because we have the exercise. We need to finish the timestamp solution live to get the time lapse between each one of them, right? So let me commit this and push this to the cloud and accept. And you should be able to see our changes in the repository that I'm going to share with you in the stream right now. So let me just go into repositories and have the security week. And let me share with you the. So yeah, now I think you are able to see the repository. It is called Security Week, and let me share with you here. And now you should be able to see the repository, the link, and with that you have access to all the information that we were seeing right now. And with that, I think that should be all for this session. So sorry for not being able to finish the exercise. I think you can be able to finish it. Thank you so much for being with me in these 3 days. I hope we can finish the exercise in between them. If you have any questions, if you want to apply to the GitHub Student Developer Pack, if you want to apply to the GitHub Campus Expert Program or anything like that, just send me a message. I would really enjoy to bring you to the program or to help you to obtain your GitHub Student Developer Pack. So don't worry about that. So yeah, thank you so much for being with me in this Global Hack Week. I hope to see you in the next Global Hack Week. I think the next Global Hack Week is in July, and the next edition is going to be the season launch. So I think this is like the new way of. I think this is the new Global Hack Week in it. But no, this is just the season launch. So I think this is going to be so fun. And don't forget that our partners are GitHub, Twilio, and Stack Overflow. So if you have any questions, go for it. Ask them in the GitHub in the MLH Discord server. So again, thank you so much. I think that should be everything for me. Thank you for being with me. And I'll see you on the next month. See ya.